Hi there, and welcome to the WeSys webinar. We're so pleased to have our strategic partner Cisco here presenting on cloud security architecture. My name is Lynn Dome, Women in Cybersecurity Executive Director. We often go by our acronym WeSys, W-I-C-Y-S, as in We Sisters, because that's exactly what we are. We're a cyber sisterhood. We're a 501c3 member-based organization that has over 70 or has over 5,000 members with representation in over 70 countries. We have 40 professional affiliates and 130 student chapters. And our mission is to recruit, retain, and advance women in cybersecurity. And we do so by creating opportunities. We have an online member forum where all our members can network and connect. Within the member forum, we have special interest groups like neurodiversity and cybersecurity, Latinas in cybersecurity, cybersecurity law, and data privacy. There's always a conversation for you in the special interest groups. And if not, you could always feel free to launch your own. We have skill development training programs such as the Security Training Scholarship made possible by Google, Bloomberg, and Facebook. AWS has beginner, intermediate, and jam sessions. Target funds gamified cybersecurity challenges. SANS Institute provides CyberStart licenses to all our members, and we have so much more. We have newsletters and webinar series, scholarships, grants, and awards for the WeSys conference, which is March 17th through the 19th. We also have those applications for scholarship grants and awards open right now for our conference. And that's available until October 18th, in addition for our call for participation for that conference as well. We also offer scholarships to other conferences. We have a cyber talent emergency fund where students within their last 4 semesters of graduating from college can apply for financial funding up to 24 hours or 48 hours. They'll receive funding for items such as medical bills or for their rent, or if they have a car expense that they can't afford, because we want them to not get derailed from their studies and to stay on their cybersecurity pathway. We have speaking and media opportunities because we want our members to be what others can see, and that's the cybersecurity professionals that they are. We have a job board plus where all our strategic partners recruit from and post their jobs in year round. And all our members could update their profiles and upload their resumes in the job board as well. We have apprenticeship programs, a veteran apprenticeship program, an internship. We have leadership summits, virtual career fairs, in-person career fairs, a veterans and military spouse assistance program, a mentor-mentee program, which we're so proud to say that we have 1,000 WeSys members enrolled in, again, for the second year in a row. That's a 12-month structured framework designed to upskill and up-level women no matter where they're at in their career, preparing them for their next level of advancement. We have a racial equity committee to lead us with equity, allyship, and inclusion and what that looks like, and so much more within the WeSys organization. And we offer all of that, and a special thanks to our strategic partners. AWS, Bloomberg, Carnegie Mellon Software and Engineering Institute, Cisco, that brings us our webinar here today, Facebook, Google, Lockheed Martin, Microsoft, Optum, AbbVie, JP Morgan Chase and Company, LinkedIn, Navy Federal Credit Union, Nike, Sentinel One, Wayfair, Workday, Accenture, American Airlines, Arctic Wolf, Champlain College, Dell Technologies, Envestnet, Flatiron, Fortinet, Haystack Solutions, Here Technologies, The Home Depot, IBM, Indiana University, MITRE, Motorola Solutions, Oak Ridge National Lab, Palo Alto Networks, PayPal, Salesforce, SAP, SANS Institute, Schlumberger, SmoothStack, SpearTip, Starbucks, Target, University of California, San Diego, and Verizon. And I want to encourage you today to ask Sanita questions during the Cloud Security Architecture webinar brought to us by our strategic partner, Cisco. So at the bottom of your screen, you have a portal there for you to be able to ask those questions. And when she's done with the presentation, she'll be sure to open it up for a Q&A. So without further ado, I'd like to go ahead and introduce our presenter today from Cisco. And Sunita, I'll have you take it from there.
Thank you, Lynn. Welcome, folks, and thank you for this opportunity. So I will be talking about cloud security architecture, and what we'll see is some of the layout that the presentation will have is we'll look into what is cloud and why cloud, why offers are moving to cloud. And we'll go into some of the happenings in cloud in 2021 and why there's a cost. And then we'll step into some of the building blocks for securing the cloud offers, which will then help us look into fundamental building blocks of that secure layer. So what is cloud, right? So cloud is essentially when all the resources that are used by the offer gets managed by a third party, and they are called as a service provider. So you might have heard some of the more famous cloud service providers, such as AWS, Azure, GCP. So those are the service providers, and they essentially manage resources. So if we see the resources are essentially the CPU, which constitutes your computing resources, the storage, which is where information data is being stored, like your database, and networking is essentially, the connection between all these different entities within the cloud or within the service provider that's also managed by the service provider. So what we see is we call a cloud when a lot of these resources are managed by a third-party provider. And with this, what we also get is the resources are shared by many. So we may have many customers using the same cloud, but they are separated, but using the same resources. They're sharing the resources. So two fundamental things of what cloud is essentially the resources are managed by a service provider. It's not managed by in-house, and the resources are also shared by many. Now, some of the popular cloud offers are SaaS, PaaS, and IaaS. So SaaS is when we have just the application running in the cloud, when you have a customer application running in the cloud. So in this case, the customer only has access to their application, but nothing within what the cloud provides. PaaS is platform as a service. Now that the customer has access to a little bit more, like the operating system and so on. So they can actually define some policies or have a little bit more control on those entities. IaaS is infrastructure as a service. This goes into the hardware, the different VMs, the different virtual machines they may have. So some amount of control to that level is made available to the customer by the cloud service provider. That's the IaaS model. So between these three models, we find most of the cloud offers that fit within these three models. So what we've seen here is a lot of these endpoints are able to use the same cloud service. Say, for example, if they have a SaaS offer, the endpoints that can connect to the SaaS to that SaaS offer can come from different places, and this helps to cater to different clients. Also, if we see, some of the industries, like for example, ride sharing. If you look at Uber and Lyft, they actually had to change or have to update the resources that are being used based on the time of day or based on maybe it's a holiday, so they require more ride sharing requests coming in. So we see that there's a constant requirement of changing these resources. And that's the reason we see a lot of these services moving into the cloud. So that's the why cloud piece. So what we see is the cloud offers elasticity. They can reduce and increase resources as needed, and they can quickly spin service. So if they need to get a new service started, but they don't want to invest in capital investment, then that's a reason why they would go to cloud. So what we see is at the end, there is more movement from CapEx to OpEx. So instead of capital investment, there is more investment given to operational side. Let's look into some of the cloud happenings, right? So we saw why offers are wanting to move to cloud. So we look into some of the cloud happenings. Happenings is breaches that we came across in 2021. And the Colonial Pipeline, this was a popular one or something that made the headlines. So essentially, U.S. had to declare a state of emergency, and the reason behind this was a VPN password that was being reused from a different place. So one of the employees' VPN password was compromised, and the hackers got in through that interface and essentially compromised the entire system. So this resulted in the pipeline being down, and as we read in the news, a lot of East Coast was down with no gas. So there is a lot of requirement or a lot of importance that these offers carry because they do support a lot of infrastructure, as well as they're open to bigger surface surface area of attack. Now, a couple of other ones, CNA. CNA was it's an insurance company, so it's a Continental Assurance Company of North America, and they were hit with ransomware on May, and they were asked to pay about $40 million. And essentially, the way they were attacked was a browser update that was fed to one of the employees' workstations or laptop, compromised that system. And then there was a network lateral move, which essentially got them through much more of their systems. Acer was another big attack. And this was one of the ransomware groups, the REVIL. That was the hacker group which got on to the Acer. This was in March, and the ransomware was almost $50 million on this. So again, here what we see is there was an issue with Microsoft Exchange Server that Acer used, and since they could not patch it in time, that was compromised, and the attacker was able to get to some of the financials, and that was the ransomware that that they threatened to leak it. Now, going into a couple more, we have universities, we have healthcare. So university, the Howard University, this is in Washington. So their systems were down, and they suffered with not having a backup. So that's one of the other issues we see with lack of security in looking into backup. So they're not able to restore the system, and that becomes a reason for ransomware. Lastly, another example is the healthcare, and this was in the Denton County, Texas, and apparently a lot of COVID vaccination records were leaked, and the reason for this was unauthenticated API. And it happened in the unauthenticated API was in a third-party library, but the source of the issue was because of an unauthenticated API. So we do see that some of these cloud offers that were hit with ransomware lacked some of the fundamental security bearings that is required for a cloud offer. So now we discussed some of the issues or some of the attacks seen in the cloud. We're going to look at and see what would make these offers a little bit more secure. So there are these three fundamental pillars for security, and more so for cloud security, because we also talk about configuration and operational. So any offer needs to be built secure. And we'll go into some of the details of what it means to build secure. And configure secure, this comes more into a cloud offer. And one of the examples I can give here is recently they had a Black Hat conference, and one of the findings was by the Wiz.io group, and what they found was they specifically found this on AWS, but it could have it could also be on different cloud service provider. So on AWS, they essentially said that some of the services, in-house services like the CloudTrail and AWS config and the serverless repo, they have been given some permissions to access cross-tenant repositories like cross-tenant S3 buckets and so on. Now, for those who don't know S3, that's the storage that's used in AWS. So essentially, some of the services, so although the offer is built secure, and some of the services, the default services, are configured not secure by default. So that's something that that we may need to pay attention when we look at cloud offers. In this particular case, one of the big issues was that the serverless repo, which is essentially used to store and deploy customer service serverless apps, had cross-tenant access to customers' S3 buckets. So it could read information from S3 buckets because the serverless apps were stored there. And given that there was no initial policy, no resource policy control on which entity could read from a given serverless repo, from which which endpoint can use a serverless repo to reach from which S3. There are three things here. That was a policy that was open. So it's very essential to look at how to configure an offer secure, especially if it's in a cloud. Right. The last pillar would be operational. So once we have it built secure and we have it configured secure, the last one is operational. When it is running, how do we make sure that we're looking into security events coming in, and how do we ensure that there is no anomalies in the system? And if there is an anomaly, is there a way for us to rectify it and go back and have it function as we need it to run? So that's the operational security, and we'll go about it a little more in depth. Now, when we go from build secure to operational secure, the thought is that we have to use DevSecOps, and DevSecOps works in every layer. So essentially, we are developing, we are testing, and we are operationalizing. Now, since we looked at the three pillars of security, we'll deep dive into each of them, and then go into some fundamental controls that can be brought into each of these phases. So build secure. So what we see here is when we're building an offer, have we identified who needs access to the offer, what levels of access, so do we have access control, which is, and some of the things that we can look there is, does it have multi-factor authentication? Have we defined roles? Have we defined least privilege? Identity management? Who would manage the identity of the user who's able to use the system? The second is continuous threat model. Now, as we know, for a cloud offer, it's not just one development done and deployed in the cloud. The development happens every few hours, and new features get pushed onto the cloud. So there should be a process for continuous threat model, wherein they just, for any new feature that is going into the cloud, they go through the design, the architecture, and revisit, right? So it should be something that's built within their development model. The next thing we see for build secure is how are they plan to store their secure information. This could be encryption keys, or this could also be sensitive data or privacy data. So have they designed, have they architected how to store secure information? Now, secure storage is, securely storing that information. And some of the entities that can be used there is Vault, or key management that comes from AWS. Azure has its own key management. GCP has its own. So there is a requirement for developers who are building cloud offers to identify what methodology of secure storage that cloud service provider offers and build your APIs using that. Now going to the next one, that's the network diagrams. Now, as we saw in the case of CNA, there was a lateral movement, network lateral movement. So it is essential to have that network diagram built up before, maybe even part of design or architecture, just so we understand the ingress and the egress traffics, as well as what checkpoints we need when the traffic is coming into the cloud. So looking into network diagrams, defining what segmentation is needed, any segregation, any firewalls, and we'll look a little bit more deep into this. Firewalls come in many different features. Some of them are the web application firewall. There's also the intrusion prevention firewalls and so on. The next would be hardened application. So when they're building the applications, they want to ensure that the applications that they're building is hardened. It follows AppSec principles, which is, it has mitigations for all the injection vulnerabilities, cross-site scripting, CSRF, and all of these actually come in the next bullet, which is hardened components. Once they build, they can actually run it through the CIS benchmark, which actually looks at the image and flags and says, hey, is it meeting some level of security? So hardened infra and application, when you're building the application, ensure that it is built securely. Updated code base. Now, this is another area that's hit many of the offers when we've seen that they've been attacked, because a lot of offers use third-party and not being able to keep up to the latest. In fact, I think just today or yesterday, Apple released another new version for the iOS. So need to keep that code base updated. Otherwise, that becomes an easy an easy way for an attacker to find vulnerability in the code base. The last thing is updated open source. It pretty much talks about the same, but also want to touch upon supply chain security and malware detection. So in some of these attacks, we do see that once a system, once the system was compromised, they install malware. So without a detection, then that would not be, essentially there's no detection. The other place, another weak link where this can get in is supply chain, wherein the build systems need to be kept secure so the malware doesn't get in that pipeline. All right, so we spoke about some of the facets for building an offer securely. Now going into what's involved for configuration and operational is essentially for configuration, we would look into if access control is configured correctly, if the storage rules are configured correctly. So in the case of AWS S3 bucket, the configuration rules would check for is there any public S3 buckets open. The access control rules would check to see if there is MFA enabled for all accounts. If there is a root account that's still operational, right? So those are some of the configuration checks that would need to be run on the image before it can be deployed. The next is logs and events. Now, we've called this out in configuration because logs and events need to be configured as part of capturing any of the events that would occur later on. So when we go into operational, we see, hey, we got this alert and we have to run it through audit, but we can only get those alerts if it has been configured. So logs and events are very important because that's the only way that that operations or your SOC team can find out that there was something, that there was an anomaly that happened that was out of line. The other configuration item here is the CIS benchmark. So these are the benchmarks which will lay a foundation to say where the security of the offer is. And again, it also helps with saying that if we find something other than what the benchmark has, then that's an event that we need to look at. Some of the other things that we've called here is VAS, firewall, ingress, gateway. Now, these all come as part of the networking, but this is something that needs to get configured for it to come into play during the operational. So network design and rules, bastion host. I'll talk a little bit more about this later. This is essentially a jump server, which is needed to get SSH or RDS from outside of the cloud to inside of your offer. So these are the facets of or areas that we may need to look at to ensure that we've configured the system correctly. Once that's done, we move into operational. So with operational, what we're seeing here is the system is running, the offer is deployed, and we've started monitoring and scans. And what monitoring essentially does is looks at the logs that we have set up here. And if there is an anomaly there, that's when it gets an alert. It's fed to an audit team. And if this is something that requires remediation, say for instance, in the configuration, we had actually opened only 2 ports for ingress traffic. But when we got this log and alert, we are saying there are 5 ports open. And since we did not open it as part of the offer itself, this could be an anomaly. So we audit it, and SOC takes the remediation of closing those ports. Right. So this is a loop, and it has to have continuous monitoring and scanning. And in fact, for a cloud offer, the operational secure becomes one of the biggest security requirements when compared to the others, just because there is a way to minimize damage or minimize how much data loss to the system at this point. And I'm also called data backup here because once the offer is deployed, the data constantly keeps changing, and that needs to get backed up. What we saw in the Howard case, the Howard College case, is they lacked a data backup. So the class was way down for a week, and they're still trying to figure out how to bring it back up. So data backup is very essential. All right. So we saw the three pillars, for securing cloud offer, and we'll now look into some of these controls that would come into effect for each of these pillars, right? So the first control would be access. So how do you secure access? And I have given some examples from AWS, but I've given some links in the references for Azure. But just as a top level, just to go through what secure access is, essentially AWS gives something called as an identity access management service. It's a service that AWS runs, and it allows every user or a group or role to have an identity. And based on that identity, we can define policy and say, for this identity, I want to define a policy, or you can actually define them separately and then attach a policy to the identity. So you can say I have a policy which gives access level such as read and write, and then but not any other access, and I want to attach this policy to a particular user or a group of users. So we can always control who has access to a resource based on the identity and the policy defined for the identity. Now we see that if it's a user, there is also, or a group, if we want to give them credentials, if we want to check their credentials through a federated identity, there is also possibility of aligning with that. Or if we say we want to just associate this particular user or group credentials with a password or a multi-factor authentication, that is also possible. So we saw this in the Colonial Pipeline case when the VPN password was compromised because the person used the same password in many places, but also the Colonial Pipeline login lacked multi-factor authentication. So these are some of the basic capabilities that can be built to check for access. So essentially, when an application runs, you can also give access. You can also control what resources could be accessed by a particular application or by a particular function based on the IAM identity and the managed policy. For applications, the AWS allows to define something called as role, and each application can take a particular role to be able to access some of the other services that's within the cloud service provider. Okay. All right. So the next control, the security control that we want to look at is storage. And this is critical because we have seen most of the ransomware attacks are trying to get to data. They encrypt the data, and that's when the offer goes under ransomware attack, right? So it's essentially to keep the data secure, and the way to the method offered by AWS is by using a key management system, which is essentially it stores it's solution for storing crypto keys in hardware modules, and it also provides crypto operations. It has a key policy. Now, again, any resource within AWS, and I'm saying with AWS, but it'll have something similar on the other cloud service providers. So any resource that we define here always has a policy associated with it. So you can associate a policy on who can get, who will be able to access those keys stored in KMS. You can also write policies on what those keys can access. So essentially, the data which is encrypted and stored in RDS or S3, it can actually, we can define the policy so that only certain users, which are also tied with the identity management, can access the keys as well as can get to the data that is stored in these storage resources. There is an interface for if a user wants to access, there is an interface for applications accessing KMS. So KMS is specific to AWS. There is also, I would also like to bring visibility into Vault, which is mentioned in the earlier slides. Vault is another third-party key management system provided that a lot of cloud offers use, and it essentially helps in separating where the data is and where the key is. So Vault is another solution that you can explore if you're trying to look at storing for a solution to store keys securely. All right. So the last control would be network. How do you secure the network? So what AWS gives is it is constructed based on the virtual private cloud, which they call it as a VPC. And so when you zoom out and look at the entire cloud service provider, it's just a single hub of resources. But since we need this separation between different customer tenants, we need to have a way to segregate the network and the resources and control the resources to be accessed only by a certain customer tenant. So what AWS does is it provides something called as a VPC. And it allows the creation of subnets within VPCs. So we can have, so every construct that's available in networking is available here. So we can have, so the VPC is associated with a set of CIDRs, and which is networking range of IP addresses. And the subnet itself, VPC can have many subnets. And the subnets can be given a subset of the CIDR addresses. We can have a public subnet and a private subnet. So the public subnet is something that can that's allowed to talk to the external internet through here. But a cloud offer can also have private subnets when they can say, we don't want the subnet to talk to any external internet, but it can only go through additional firewalls to get there. So this is a very simplified information of AWS networking. There is a little bit more, but I can just talk to what we have here. So essentially, you can have many subnets, and now looking into some of the resources, right? So the subnets are associated with those IP addresses, and IP addresses are assigned to your compute resources, to your virtual machines that constitutes your compute. And I've shown that you have applications running on this because it's a compute resource. Now, by default, every VPC comes with network ACL and security groups, which essentially say how the ingress and the egress traffic should be defined. But since cloud offers require more sophistication, they also offer different layers of firewalls. So starting from here, this is, when an application is trying to access, when an endpoint is trying to access application features, they come through something called as an internet gateway. This is the regular gateway that we all know, and there are rules defined here. Now, once here, the customer or the offer can add additional firewalls. So if they have a web application running, they can add a WAF, which essentially does a little bit more traffic lookup on and ensure that the basic web application vulnerabilities are not being hit. So it does scan the request and ensures that the request doesn't have a script which might cause cross-site scripting and so on. So it just flags. So if we want such a feature, then the offer can take a WAF. So this is intrusion prevention and data inspection. So there are many more very sophisticated firewalls which actually look at traffic and flag. If you've set up logging here, it does send an event, it does send an alert. That way, when your operations is running, you get those events and you can act on it. So those are some of the feature-specific firewalls. There are more features. I have just given some fundamental ones here. And then if the customer wants their own firewall, so these are some of the firewall features given by the cloud service provider. Now, if the customer wants another firewall, which is their offer feature specific, then they can put in their own firewall. And AWS also gives access if the offer wants to talk to on-prem devices. There is a way to set up VPN. There's also VPC endpoint, which is an internal link, which will allow services in this network group to talk to some of the common AWS services like the RDS and storage. They can put a VPC endpoint, which will allow that traffic to go through. So these are some basic networking design ideas and thoughts that need to be given when we're looking into designing the networking for the cloud offer. Last, there was this bastion host. Now, many times an admin needs access and SSH RDP access into the system, and there we recommend using a bastion host. It is like a jump server, so if there is no direct link to your internal systems. So that's the other recommendation that's here. Okay. All right. Lastly, we want to talk about monitoring and scanning. This again, as I said, is probably one of the most important controls that you want to bring into your cloud offer, because it's a way to keep your cloud offer secure and to minimize the damage or the lateral move that we saw in many of these attacks that happened in 2021. So some of the things we want to call out here is configuration scanning. So before deploying, we need to scan the configuration and ensure that it meets the CIS benchmark. All the major cloud providers like AWS, Azure, GCP, they all have given benchmarks. So which essentially looks at for identity management, it looks at whether MFA has been defined, whether root is still there, whether password meets certain password requirements, and the strength of password, and so on. So all of those are built into the CIS benchmark. So that's something that we have to run. And also it provides, just find out the baseline for what you've defined for identity, storage, and network, the baseline security that has been defined there. And that would give you the configuration scanning. Then we go into the operational scanning, which is essentially vulnerability management, which is constantly running in your deployed service to ensure that there are no new alerts being seen with respect to ports being open or services coming up. So those are some vulnerability management scans. Or those are some of the issues that vulnerability management scans will catch. Now going on to the next one is operational monitoring. So operational monitoring is, so we have the scans in place and we have to set up something to monitor so that we do something when the scans say that they're finding something abnormal. So there are host logs, there are infra logs. Now infra logs, one of the big logging here is for AWS is CloudTrail. So in each of those controls we saw, access, network, and storage, we can actually define CloudTrail events and alerts. And once we define that, then if there is an event and alert, then we can send that to the SOC and then have them analyze and see if there's something out of normal. Host logs are those that host monitors are those that monitor the operating system or at the host level. Some of the examples here is OS query and infra logs. We did talk about that, the CloudTrail. And finally, CM handler, right? Once you get all of the logs, we actually have a CM handler, which actually looks at the logs to find out those anomalies. So it's important to have that CM handler. So that would be the operational monitoring piece. And through the monitoring and scanning, as this is something that's going to be always running on the deployed system, it's important to include penetration testing and evaluation intermittently, especially for a cloud offer. This should be part of the operational security when there is intermittent checks, because as we discussed, the microservices get added very frequently, which means new code is getting in, which means open source would get in. So unless there is a constant penetration testing, new code, which may be vulnerable code, might get into the operational the offer that's running. So That's all I had, and I want to thank Wix and the CWix for giving me this opportunity.
Beautiful. Well, we could go ahead and dive into some of the questions that came in. Are we ready to maybe turn down the slides? We could show our faces for the Q&A session. Sunita?
Yep.
Okay, there we go. There we are. All right, so we do have some questions that came in. It was a great presentation. Thank you for your time and attention. And of course, we love and adore the Cisco partnership and you taking the time out of your afternoon to share your knowledge and expertise with all our members was just a great help to our community. So we appreciate it. All right, so the first question is, when does it make sense to offer to not move to cloud?
Yep. So yeah, since we spoke so much about why offers are moving to the cloud, it makes sense to also perhaps maybe understand why an offer may not want to move to cloud. So most of the reasons there would probably be if it's a defense offer, when they want to have tight control of where the resources are. So those would be the use cases. Or in some cases, if there's a geographical control for nation states to ensure that their resources or their keys are stored in some particular location, wherein a cloud service provider cannot provide that. Most of them do, but maybe that's another case when offers may will continue to stay in-house.
Got it. And I just want to remind the audience that on the bottom of your screen, there's an option there for you to put your questions in. So we're going to ask a couple more questions here, and we'll hopefully get to all your questions before the top of the hour. So how do I choose between different cloud providers?
Yeah, so I think today we have three major ones, AWS, GCP, and Azure. There are many more smaller ones, and it basically depends on the amount of service we would like to use in that particular cloud service provider. For instance, AWS, we saw they have CloudTrail, they have AWS Config, they have a lot of services. So the entity using it, the BU or the company using a cloud service, will probably need to see how their other services are aligned. Are they using the same cloud or not? What are the provider contractual agreements, and what is the cost for rolling out their tenant on a particular cloud? And also the architecture, right? We know that some of them, like GCP, provides hardware security, but AWS and Azure are still building that, or they might just have it now. So I think a way of looking into it is cost, as well as what are the features that they really need to stand up their offer.
Yeah, very good. Good information and good guidance there too. So what are some of the industry forums in cloud that people can participate in?
So one of the big ones is the Cloud Security Alliance, and they in fact come up with a lot of security controls, and it's being used. Their controls are used by people building secure clouds, by auditors auditing if the cloud is secure, and essentially, even the ops teams to ensure if they're looking at the right alerts, to ensure that those controls do let them know if there is a critical alert or not. So Cloud Security Alliance is a big one. Also, a lot of these industry conferences do have cloud. They have a cloud, either a cloud summit, or they have a forum where they discuss only cloud happenings in the cloud. So those are also interesting places to connect into.
Great. Yes, Cloud Security Alliance just had their conference September, so I saw a lot of activity on that on social media. So it seems like a good place to get started when you're looking and navigating your way through the different type of forums there. And a question just came in is what certifications do you recommend to break into cloud security from entry-level cybersecurity candidate?
Certifications is training is what I understand. For training, essentially just understanding the the basics of security. There is also certifications from SANS, which has I think CISSP was just the basic security that everybody needs to know. But there's also one that they provide for cloud security, and maybe you can actually look into taking a test there and getting your certificate from them. Those are some options.
Yeah, WeSys ourselves has been looking into putting together a cloud security training program because we do understand the need and kind of to break into that kind of ecosystem is for us to kind of consider what it would look like to put together something with cloud security. So everyone that's paying attention, make sure you subscribe to the WeSys newsletter so that you could learn more information if and when this program does get rolled out in the near future. So that's really great. Thank you again for your time and attention for presenting this great information. Everyone that is on the presentation today with us, we appreciate you carving out some time in your afternoon and sharing your precious hour with us. You'll also be receiving a recorded copy. And if you have any additional questions, feel free to reach out at info@wesys.org. So that's a wrap. Thank you, Sunita. I really appreciate you taking the time to present today. Have a great afternoon. Bye-bye.